Where are you? When are you? These questions seem simple, but they're at the heart of the universe's greatest mysteries. Space and time aren't just empty ideas, they're the fabric of reality, the stage for everything from atoms to galaxies. Imagine the universe as a vast ocean. Space is the water, time is the current that carries everything forward. Without space, there's no here or there. Without time, there's no before or after, just a frozen instant. For centuries, we thought of space as a fixed box, and time as a universal clock. But the universe is far stranger than we imagined. The motions of planets and the speed of light revealed that space and time are deeply connected. They're not separate. They're two sides of the same cosmic coin, woven together. So, let's set sail on a journey through space and time. We'll see how they stretch, shrink, and warp in the presence of matter and energy. This isn't just physics, it's about understanding our place in the cosmos. From the Big Bang to the far future, space and time shape everything. Come with me. What is space? It's the three-dimensional room everything occupies: length, width, and height. Think of your bedroom. You move forward, backward, up, and down. Every object has a unique address in this vast expanse. Space isn't just an empty container. For centuries, we saw it as a passive backdrop, like a stage for the universe's actors. Newton imagined space as a perfect, unchanging grid. But let's use a fish tank analogy. The tank's volume is space, and objects inside have distinct positions. We measure space every day, walking to the store, arranging furniture, building houses. But here's the twist. Space isn't passive. Imagine the tank filled with jelly. Place a heavy ball inside, and the jelly sags and deforms. Space, too, can bend and warp. It's not a rigid stage, but an active participant in the cosmic drama. Matter and energy can curve space, changing the rules of geometry. The universe's structure depends on how space responds to what's inside it. Space is dynamic, not static. The cosmos is full of surprises. If space is where, time is when. The river that separates past from future. We experience time as a steady flow. You remember yesterday, anticipate tomorrow, but can only live in the present. Every event happens at a specific moment, giving order to the universe's story. Think of a movie. Each frame is a moment, and the sequence creates the illusion of motion, just like time in our lives. For centuries, we believed time was absolute, a universal clock, ticking the same for everyone. Everywhere. Newton called it a steady, impartial flow. But what if time's river could speed up or slow down? The universe revealed that time is relative. It can be stretched or compressed by motion and gravity. A clock on a fast-moving spaceship ticks differently than one on Earth. Gravity can slow time near massive objects. Time isn't a rigid ruler, but a flexible, dynamic quantity. Our experience of time depends on where we are and how we move. The flow of time is as mysterious as space itself. Space and time aren't separate. They're woven together as space-time. Picture a stretchy rubber sheet. In empty space, it's flat. Place a heavy object on it, and the sheet curves. That's how mass and energy warp space-time. Gravity isn't a force pulling objects together, it's the result of objects following curved paths in space-time. The Earth orbits the Sun because it's rolling along the curves created by the Sun's mass. This curvature also affects time. The stronger the gravity, the slower time flows. Gravitational time dilation. GPS satellites experience this. Their clocks tick faster than ours on Earth, and engineers must correct for it. Motion also warps space-time. The faster you move, the slower your time passes. Special relativity's time dilation. Imagine twins. One stays on Earth, the other travels near light speed. The traveler ages less. They've experienced time differently. Space and time stretch and shrink, depending on gravity and speed. The universe is a flexible, dynamic fabric. Our everyday experience hides this cosmic truth. Space-time is the real stage of reality. Everything moves and changes within its shifting landscape. The rules are stranger than we ever imagined. Before Einstein, space and time were thought to be absolute and separate. In 1905, Einstein's special relativity changed everything. The laws of physics are the same for everyone, and the speed of light is constant. To keep light's speed constant, space and time must adjust. Distance and duration depend on the observer's motion. Moving objects contract in length and experience slower time. 10 years later, Einstein's general relativity revealed gravity as the curvature of spacetime. Mass and energy tell spacetime how to curve. Curved spacetime tells matter how to move. The sun warps spacetime, and planets follow curved paths. These ideas revolutionized our view of gravity. Einstein's theories are tested daily. GPS relies on them, and astronomers see light bend around galaxies. We've even detected gravitational waves, ripples in spacetime from colliding black holes. Spacetime is the best description we have of the universe's grand design. Why does spacetime matter? Because it's the foundation of everything. The Big Bang wasn't an explosion in space. It was the birth of space and time. The universe's fate depends on spacetime's shape. Will it expand forever, collapse, or coast to a halt? By studying galaxies and cosmic structure, we measure spacetime's geometry. Black holes are regions where spacetime curves so extremely that nothing escapes, not even light. At their centers, our current physics breaks down. To understand black holes, we need a new theory that unites gravity and quantum mechanics. From Earth's orbit to the light from distant stars, everything is governed by spacetime. When we look at the night sky, we're looking across space and back in time. Spacetime is our vehicle for exploring the universe. We've come far, but mysteries remain. Einstein's relativity describes the large, quantum mechanics the small, but they don't work together. At black hole centers and the Big Bang, our theories break down. We need a quantum theory of gravity to understand spacetime's true nature. Is spacetime smooth or made of tiny pieces? We don't know. Dark matter and dark energy make up 95% of the universe, but remain mysterious. Is our understanding of gravity incomplete? Why does time only move forward? The arrow of time is tied to entropy, but its origin is a puzzle. The nature of space and time is still one of science's greatest unsolved mysteries. The journey to understand spacetime is far from over.